Hello, everyone. My name is Pinak, and this is Rapas. We are presenting a research paper called CO-EXISIT, which focuses on the multi-species design in Galapagos. So the Galapagos Islands are a group of volcanic islands, and they're located off the west coast of Ecuador. These islands host a large range of delicate ecosystems and species. These species have been subjected to various sorts of anthropogenic factors, and over the years, these anthropogenic factors have also been responsible for creating a very tough situation for these species and their survival. In this research, we are going to see how these species can be incorporated into architecture and how the humans can act more cohesively to integrate these species into the daily lifestyle. So for this, we divided into three segments. The first part was an in-depth study of the ecosystem and the respective species. It also studied the existing settlement and human habitation. The second part compares the ecosystem study to the current human population and its effect on the biodiversity to propose a suitable urban development strategy. Lastly, we investigate by the evaluation of the environmental parameters of the species to integrate the shared boundaries between species and humans. So this design research focuses on the island of Santa Cruz in the Galapagos, which is the most densely populated island, with 4 different ecosystems. The research was divided in such a way that we studied the arid and coastal ecosystem, where the humans and the species are in close contact. A multi-species linkage was marked out based on their interdependency, foraging, and migration patterns. The key species were identified with each playing a different role on how they affect each other's survival, and the terrestrial species of the giant tortoise, iguana, and the cactus and the humans were taken ahead for the further exploration in this research. Focusing on the island, tourism generates more than half of the money on this island of Galapagos, and nearly half of the population are working in the tourism industry. We chose Santa Cruz Island due to its high local settlement population and maximum tourist footfall. There are 3 human-occupied zones on this island. The research focuses on Puerto Ayora town because it is the most populated town and has approximately 12,000 people. Simultaneously, we also plotted the species requirements based on the factors of humidity and temperature needed for the species. The daily timeline activity of each species was also marked out for us to understand which activity can be combined with the architecture we are proposing. Lastly, a catalog was prepared where the activities were based on the parameter requirements to understand how each species activities can be integrated into this cohabitation model. So based on these, we found the gaps in the research, and the following questions were asked for us to move forward. They pay attention to the key species and human relationships to implement cohabitation in this island. So now we move on to the cohabitation strategies part and focus on the next 3 developments.
Yes, for the urban and settlement planning. The chosen area of the intervention shall act as an extension of the city and centrally located zone between the existing zone of the key species and the city. The study on the giant tortoise migration or in Santa Cruz is potential for urban planning. Seasonal migration patterns were used to identify water collection points for mud parting, forming a potential ecological corridor. Rainwater channels were marked to address freshwater scarcity, serving as an access point for tortoise. Additionally, common links among species were traced to diet and ecosystem contribution, especially the seed dispersals. On the existing terrain, we identified giant tortoise migration zone. Then we marked the water collection points with the respective quantity of the water contribution based on the average rainfall received in the Puerto Ayora city. Then we create a corridor for the tortoise by identifying the shortest walk from the highland to the lowland, passing through the swamps. So we provide these swamps for the tortoise to be their resting zone for their migration. For the other location of the pond, we use as the water collection pond for the human consumption. Then we calculate the water usage and average rainfall in the Galapagos to determine the pond's capacity for supporting the population. Then the proximity of the pond was established to facilitate the formation of sediments. To identify the area of sediment, we set up the genetic algorithm experiment to optimize sediment area and control descent of the castor. The sediment will avoid water channel area and region with the slope exceed 10%. These are some of the results, and we took the best performance of the objective. Following that, the link between settlement were established to construct the main road with the priority given to the northern settlement and the existing city. On our main road, we have 8 meter width with the pedestrian and bike lanes. We also simulate the centrality of the main road to establish the main area for the facility area. So, and then we select the eastern settlement, which is the closest settlement to the existing city, to be our site for the clustering experiment. In the previous experiment, 80 square meter block was created to meet the housing needs. We calculate unit based on local and tourist population, resulting in 3 main housing type. So we have about 1,500 people for the next decade. The eastern settlement has been separated into 5 clusters by water usage, when their total capacity to accommodate 190 people. Then the experiment was set up by create various bulk pipe within cluster to optimize unit distance and control the proximity of the pond, thereby reducing water supply infrastructure. These are the results that have a good performance in our objective. So we selected the result which have less distance between units and ponds. And then we established the sub-road with 4 meter width.
So now we focus on the housing morphology and the unit development. The housing design was handled in 2 parts, the unit design development and the material and construction methodology. Moving on to the material, we selected a material called bioceramic. This was formed by looking at the water management. As there is fresh water scarcity, they use desalination plants for the water provision, and marine eutrophication also uses wastewater management systems. So the waste that is generated has elements like magnesium and phosphorus. These elements, when combined with sand and wollastonite, give a very high performance material for the local brick production. Bioceramics also have a structure and properties which are similar to ceramic and concrete, which means they are better in compression than tension. So after recycling of bioceramics, the magnesium and phosphorus can also be returned back to the earth. The experiment and literature review provided us with tensile and compressive strength data for the material, and these values were utilized in the research further. So moving on to the settlement, we overlapped the tortoise traveling capacity of 200 meters per day marked in the yellow zone, and this allowed us to include the possibility of a movement allowance for these species within the settlements. So a strategy was formed. The primary strategy was to lift the structures which can maximize the species movement. Second was to see the foundation that touches the ground can have a minimum footprint. And lastly, the whole structure could act like a good opportunity for sharing the resting spaces between humans and the species. So a hexagonal footprint was chosen with an offset for extruding the plinth. This plinth was further having subtraction for creating a movement of the animals below the plinths of these structures. The next was to see how the footprint reduction could take place, which could ensure that we have less than 20% of the ground structure onto the touching the ground. The outer footprint held a shell structure that encompassed the humans and the animal spaces together. Thus, the primary morphology had further two extensions which catered to different types of units of 80 square meters and 100 square meters. A multi-objective simulation was carried out later, which gave the results for us in terms of the tension and the footprint areas. We consider shadow to be an important aspect as they served as vital environmental factors for the species accommodation. After that, a few selected results were further post-analyzed in terms of humidity and temperature to see which of them can be used for the structures. So these are some of the catalog that we prepared for every type of unit, which shows the different variation of humidity and temperature levels to choose from. And lastly, from this, the best results were chosen and taken ahead in each type of unit for executing onto the site. We then went ahead to see the common areas of the humidity and temperature, and we marked the respective readings of every unit typology onto the catalog to see the feasibility of these structures. Lastly, we envisioned a space where the animals could move freely. They could have a sense of ownership, and they could, by the time, with evolution of time, they can utilize the space as their own landscape and move around freely. The next part of the material and construction. So a component was created to take factors of easy handling, resemblance to the local construction methods, and dimensions that could accommodate the curvature of the walls and the domes. Therefore, the material of the bioceramic had different types of variations of the blocks, and we used an algorithm for determining a k-means clustering, which formed the clusters of 5 and 10 different block formations. Later, we had to see how these structures formed by these blocks could sit onto the site. A grid plot rationalization was used where the centroids of the grids were matched with the centroids of the floor plans, and they were further implemented to mark onto the site. And thus, a cluster was formed where this grid was rationalized with the help of this floor plans.
Yes, after that, due to the average rainfall, there might be the insufficient water availability for the half of the year. So apart from the harvesting water from the pond, there's a implementation of fog harvesting net to gather extra water, and we took the August to be worst case scenario to calculate extra water harvesting. And this is the strategy that the net can capture the water droplet. And we have the 3 research on the case study, and we choose the case study with the comparable wind velocity as our site, with a spiral net on the net surface. Then we adopt that strategy to design the experiment aiming to optimize the net surface area while minimizing the displacement of the tower and solar radiation on the net. And this is the outcome. And we took the result with the average score in every objective. And CFD simulation was conducted to assess the tower performance based on the wind. And utilizing the outcome, we calculate the additional water required to attain the average rainfall in the worst case scenario. And the eastern settlement needs 21 fog tower harvesting. we create the next experiment for finding the location for the fog tower by optimize the net surface facing the wind on southeast and controlling distance of the tower of the pond and the sediments. And this is the outcome of the experiment. And we select the one performing the base. And this is the when we fill up the morphology and the fog tower. And this section shows the two important parts of the water infrastructure that connect to the filtration spot and then supply to the housing in cluster to the water service network. And the last part, the corridor. For the corridor, the height of the catad is the main problem for the tortoise. So they cannot reach the height of the catad. So we try to create the terrain to help them. Then we try to then we simulate the CFDs to understand the pattern of the wind coming from the southeast, and using the tree to create the wind tunnel to increase the wind speed and reduce the humidity. And we set up the strategy for the wind tunnel and the terrain. Yes. And this is the outcome. We test the outcome by running the CFD to see that our terrain can increase the wind velocity. And this is the connector between the sediment. We also create some area for the animal underneath. And this is the outcome that having the area for the animal, and we test the result that have a suitable humidity and temperature for them. And this is our conclusion. On the right-hand side is there's a water infrastructure, and on the left is a swarm for the tortoise and with the animal corridor and the connector crossing by. And this is our rendering of the morphology. And this is a connector that connect between the sediments and the overall view of our sediment. Thank you.
Hello, thank you for that presentation. Very interesting. And a very interesting approach also, like merging an ecological perspective with a system of infrastructure and living. I'm a little bit, I have a tiny questions, probably a bit stupid questions, because I'm just trying to understand your unit, which is this one right here.
Yeah.
Am I understanding that you're intending to, be people living there, but so as the animals can walk through there and, having both of them co-living together? Did I understood that correctly?
Yes, that's the idea.
Okay. I find that in a very nice idea, but not very probable. Because I'm not an ecologist, but what I've learned from ecologists is that every habitat needs to have their own habitat to, keep on going. So I think the intervention, there needs to be a limit of human intervention in a specific habitat. So I think that merging of creating a structure for both of them I'm not sure that's going to bode well on those kind of species. Maybe they're very friendly to humans, and I really love the beginning where you actually have all these real life videos and images of how those species live, but they're in their natural habitat. Whether we create roads or we need to pass through or we're hiking, that's our fault, not theirs. So making this intentional, I found that, I think that's my tiny criticism or a bit of a risk of how that habitat might develop. So that's my first hint. The one thing that I didn't understood quite well is the number, you propose a number of towers in each cluster. What defines your number of towers into each cluster if you have a total population of 1,500, which is not big?
Yeah. Actually, we also have the pond to collect the water, and we have the extra water to collect the fog.
Right.
Yeah, to be the extra water for the settlement. We have two.
But what defines the number of towers in each cluster?
So every fog tower has a certain amount of water that can be catered to, and this volume of water is compared with the volume that is needed by every person in the settlement.
Right.
So that is how the number of towers is decided for each of those clusters, and then you can add or subtract based on how much is it sufficient or not.
Okay. And my final comment is in your ecological corridor. And I was trying to understand also that little, lines that you created. I think it went a bit too far. I think it would be less of an intervention because an ecological corridor is just that, ecological. So I think that, putting some elements in order to enhance or protect. For me, you need to think ecology as protection as well. Not only enhancement, but how do you enhance it? How do you intervene, but also protect and preserve? So I think that went a little bit too far and let it be and grow naturally as it should be over time. I think that sort of balance between ecology and intervention, and that's, you guys did amazing work on putting the whole system together, which I thought it was great. But my one thing is, I think we went too far on the intervention on respecting and preserving the ecology and the types of species that you have. That would be my guess. But thank you very much.
Thank you.
Are you wanting to clap? I think. Congratulations, guys. It's really nice work. It has progressed a lot, and it's very nice to see it. Yeah, I mean, I'm kind of trying to convey it in my head and I think it's something that's common to all the work, because you are integrating systems and you kind of move on. And I'm trying to reconstruct maybe the argument. I think because you have been working sort of separately. You have this kind of ponds, but later on, much later on, we have the towers, so they are a bit disconnected. So I feel like these arguments, the form of the thesis as a form of argumentation for an ecological kind of compound, as Laura was saying, the balance, I think, has to do with the balance of how we go from one problematization to the next. To start with the very first one, which is why would we encourage tourism next to this city? I mean, should we, no? And I'm not saying we don't, because otherwise they will build a hotel there. So it is relevant, but maybe the kind of points of problematization that happen to articulate the responses of systems could be something that you can present in a smoother way, more consequential maybe, or when it's segregated and saying it's segregated. That's why when you start kind of operating on the ground again at the very end to help the tortoise like kind of eat the cactus, it feels a bit like, okay, what else can we do, right? It seems like we're really wanting to help. And maybe if there were more like field operations, if all the kind of topography was intervened in ponds, in topography lines, if it was more kind of holistic and less as a sort of accumulation, we could negotiate these things together. And right now they appear as local operations. But I think that's, you've built a lot of intelligences. So if you look at it like that, like you build maybe 4 systems of intelligence that respond to different conditions. And the integrations of this can be different. No, it can vary. It kind of hosts many projects. So I think the richness of the proposal is that with what you have produced is a set of tools that all of a sudden we could use to kind of design many different ways of settling in the Galapagos. So I think that's probably one of the things that I really kind of enjoyed that you developed.
Just one thing. So the part where we are trying to keep the natural habitat as well as build, let's say, a settlement. So because we had the research done before, we saw that right now they both are existing in separate zones. But the problem is that because the population is growing, it's the boundaries of those human settlements have started exceeding into the zones of the species. So like while doing the research, the idea was maybe instead of trying to push each other, can we try to integrate them and see that they could not exactly side by side, but have their own existence, but while also maintain some boundaries. So, yeah, thank you.
Hey, thank you for your presentation. I'm going to come in here as an expert because I actually have a pet tortoise. It's a Greek.
Okay.
It's true.
We should.
It's not in my house. It's at my parents' house. It's a Greek land turtle that I owned since I was 8 years old. And it's 40 years old now, and apparently it's going to live another 40 years. So I'm not sure what to do with it. But, so I always had a pet tortoise, great animals. But here's the perspective, of course, like these things outlive us, right? And these tortoises will outlive us, and they will outlive the structures that you're building. So I have the same comment really as Laura as well, is I find it slightly, weird to kind of build architecture for, for the animals, because it's. So my question really is, so you're building it's for 1,500 people. You said there's only 18,000 people in that town. I just looked that up. So you're kind of expanding it for 10%. Who is it for? Is it for tourists?
Yeah, mostly it's tourists.
Okay. Well, then it'd be interesting to kind of look at it. Tourism is not just these kind of little buildings for the tourists to live in. There's always a massive infrastructure behind it, right? That you often don't see. And if you look at these kind of tourist islands, quite often in the middle of it, you'll have this super infrastructure to sustain all that tourism. So for me, it's much more than just having the turtles being able to walk through it, right? It's all that supporting infrastructure that comes with the service industry. And that I haven't seen in your proposal, right? So I think that's quite an issue that you kind of not even touched at. And there is, yes, you talk about the water, how to capture water and all that, which is great, but there's so many other things that you don't touch on, So yeah, and the question is also kind of like, can it be more sustainable than the way you've done it now? Because I think you've tried to do that, but I think it could be much more extreme than these kind of building all these buildings there, because they will outlive us, these turtles, right? So yeah, I don't really have a question. I'm just quite concerned a little bit when you start talking about building architecture that we can cohabit. We're the invasive species, right? It just makes me think about all those foxes that kind of walk around my neighborhood in northeast London, right? It's almost, we're the ones invading their habitat. So it's good effort. I think you kind of showed a lot of expertise in trying out different techniques and technologies and all that, which is great, but I feel that sometimes you got lost in it. You kind of, I can do this, and I can do that, I can do this, and you never step back, right? I think you always have to kind of, because you can get lost in technology, and you have to step back and say, why am I doing this? What is the right thing? So it's that balance that you have to keep. Yeah. Okay.
Thank you.
Yeah, thank you for explaining your process, and I have to say I do agree. In fact, I was kind of trying to make probably the similar point to Xavier and the others, but I think you got me quite excited with your proposition at the beginning, because the coexistence with some sort of species that are also at risk of extinction is quite an interesting aspect, and you started in the right way, understanding how they move about. But I think, as Xavier mentioned, you sort of you didn't have that time of actually putting the puzzle together, and it's sort of evident in when you're actually forcing the corridors as opposed to understanding their own corridors and try not to intersect them as well with the human intervention. I think you're crossing several paths, which is one of the things that I noticed that felt a little bit than, as you mentioned, an invasion more than that kind of coexistence. But so I think I need to maybe find another point, and I was quite interested in the materiality and the topology of your, sort of installations and units. So in terms of topology, I'm curious about why you've chosen the arch, as you're creating quite a large space for tourists. Perhaps it's not quite optimal in terms of what they need it to be. It's quite monumental. It's quite nice cathedral-y space, but it brings along challenges of structure that when you bring them on a land where you should try to minimize your impact, then it's a bit of a, I've got a bit of a problem with that. And the second thing is actually the choice of material. Could you explain it to me again? You're using the desalination process, right? Okay. So the byproduct of the desalination is fed into the building up of the brick.
Yes. So there is desalination and there is marine eutrophication. Mm-hmm. So they both have their own different wastes which are generated. So like we see, the desalination plant is giving magnesium oxide, which is one of the elements. Yeah. And the eutrophication wastewater management is giving us phosphorus. Right. So
okay, so I think it's a very interesting thing, and it's obviously you did your research. I think the only slight problem I got with this one is that it's about encouraging a process that is high intensity in carbon, which is the desalination, to make a material. So I understand it's the same conundrum that we have in the industry with the GGBS in concrete, right? You use it because it's there, but it's going to finish. Provides a short-term solution, but in the long term, you're just encouraging production of a byproduct. So I think it's very interesting. I just wanted to point that out. But all in all, I think I was really, pleased to see your process and the methodologies, as Laura was saying. You've done, the tool is all there. It's just about maybe tweaking a few things. Thank you.
Thank you so much.